go to the nearest tenth. Now here I have the negative square root of 632, and I said we can't have a negative underneath the square root symbol, but I can have it outside. So that negative kind of just carries on to the outside. Now the square root of 632, rounded to the nearest tenth, is 25.1. So my final answer is negative 25.1. And then the last one, negative comes down. The square root of 533 is 23.1, and that's rounded to the nearest tenth. Okay, so not really too much mental work there, but mainly we're looking to make sure we understand the concept of what a square root is. Okay, now next here it says, think of the radical sign as a graphing symbol. We haven't talked about radical signs yet, but really this is just a code word for square roots. That's all it is. It's a code word for the square root symbol. It's another way of calling it, another name for it. So sometimes you'll hear radical and it sounds really exciting and whoa, new stuff. But it's just another name for a square root. So if I say the radical symbol, I'm talking about the square root symbol. So it says think of the radical sign as a grouping symbol. Work inside the radical sign before finding the square root. So basically we're going to want to think of whatever is underneath our square root symbol as being in parentheses. If you're using the TI2XS calculator that we use in class, it's automatically going to give you on your screen when you hit square root, parenthesis. It automatically does that because it's saying everything under the square root symbol has to be dealt with first, and then you deal with things outside of it. Okay? So example 3, evaluate 2 times the square root of a plus b squared. I'm going to substitute 11 in for a and 5 in for b, and that's b squared. I'm going to continue my symbol, and I'm going to put a little downward notion so you know I'm at the end of my square root. But I have 11 plus 5 squared. That's going to be 2 times square root of 11 plus 25. And that's going to give me 2 times 11 plus 25 is 36. I'm still working on simplifying everything within the square root symbol first. Square root of 36, oh, I know the square root of 36, so I don't even need that symbol anymore. Instead, I'll just cancel all that. Instead, I get 2 comes down, and then square root of 36 is just 6. So 2 times 6, and now I'm ready to multiply. My answer is 12. Okay, let's go to the next page. We're going to practice a few more of those at the top. And here we have example 3. You try evaluate the expression when a is 12 and b is 4. Okie dokes. So I'm going to, in place of a, substitute in 12, in place of b, substitute in 4. 12 plus 4 is 16. Now the square root of 16 is one that I know, it's just 4. Letter B, I have 2 times b squared is 4 squared minus a, which is 12. So I'm going to work everything underneath the radical, or underneath the square root symbol. 4 squared is 16, so then I have 16 minus 12. This is going to give me 4. Now I know the square root of 4 is 2, so I get 2 times 2. So my final answer, again, is just 4. For the first time, for the second time, let's take a look at letter C. This one has the most to it. It's going to be 3 times, ooh, big one, square root of 12 times 4 plus parentheses 1 minus 12. All right, so it's 3 times the square root of. Now I can multiply. I'm using PEMDAS here is what I'm following. You have to do what's in parentheses first. So I can, technically it would be 12 times 4 plus, but I know that I can multiply that right away and get that going. 1 minus 12 is negative 11. Okay. 48 plus negative 11 is going to give me 37. Square root of 37 is not a perfect square, so I don't know that one off the top of my head. Instead, what I'm going to have to do is figure out what it is. I'm going to round it to the nearest tenth. Okay, so square root of 37 rounded to the nearest tenth is 6.1. So this gives me 3 times 6.1. Now I can multiply 3 times 6.1 and I get 18.3. Okay, so sometimes you're not going to know the perfect square, but you just have to you can round it to the nearest tenth unless the directions tell you to do otherwise, so pay attention to those. Moving right along, Example 4, we're almost to the end. Solve the equation round to the nearest tenth. So what we've been doing in this first part, these were expressions. We were solving expressions. Expressions have no equal sign. Equations do have equal signs. So x squared equals 49. All year we've been solving equations. Our goal is to get x by itself, or whatever variable we have. So this is close to being by itself, but we have a 2 right here, a little exponent. So the inverse of squaring something, we said at the beginning of the lesson, is to take the square root. So I'm going to take the square root of this side and the square root of that side. When I take the square root of both sides, this squared and square root cancel one another and the x falls right down through the cracks. The square root of 49 is just 7. And that's my answer. And I can always, just like always, substitute it back in. 7 squared equals 49. Letter B, I want to get r by itself. So it's r squared right now. If I take the square root, that's going to cancel the squared and the square root symbol. They're inverses of one another. Like if you add something and then subtract the same thing, they cancel, they disappear. Same thing here. So r is now equal to 8. Letter C, I'm going to take the square root of both sides. Square root of t squared just becomes t. Square root of 121 is 11. And the last one, I'm going to take the square root of both sides because I have r squared. I only want r, so I'm going to take square root. I get, oh, that's a big one. Square root of 534. Another one that I do not know off the top of my head. May not be a perfect square. We'll find out. 534 is, nope, 23.1. And again, it says round to the nearest tenth if necessary. So make sure you check out the directions.